when we're looking at our derivatives, we know that we get rules such as the product rule and quotient rule to come into play. What we're going to look at with these next lot of questions is how we use those types of questions, but also ones where I can be when we've got log of a cos function. So again, we've got to remember all those rules that we've learnt so far and start applying them now with trig functions. So the first one is a derivative of x cos x is a product rule. So there's our function, derivative of x is 1 times the cos of x plus the x times the derivative of cos x, which is minus sine x. So if you look at that, and then simplify it, we can bring it down to cos x minus x sine x. So product rule there. This one is taking log of a function. Now we know the derivative of a log function is the derivative of the function over the function. So derivative of cos is sine, is minus sine. So there's the derivative over the function cos x. Sine on cos can be written as tan x. So we can simplify it that way. Again, this one's the derivative of the function times the function. So derivative of cos x is minus sine times log of x. And then cos of x times the derivative of log of x, which is 1 on x. And we can write that, because it's negative there, we might write it as sine x log x. And the cos x over x can be written in front because it's positive. But product rule there. So notice it's a little bit different here because it's cos of a log function. So it's a little bit different. That's two separate functions. This is one because it's cos of log of x. So when we do the derivative of a cos function, we know that cos goes to negative sine and the function stays the same, and it multiplies by the derivative of log x, which is 1 on x. So it gives us minus sine of the natural log of x all over x. So take note of the differences. It's just a subtle difference, but it gives us a different answer. So this one here is a little bit strange because it's cos of x. So again, what's a derivative of cos x? Derivative of cos goes to minus sine, and the function stays the same, and we multiply it by the derivative of the function, which is minus sine of x, which gives us a positive sine x sine of cos x. This one we're going to treat as a function of a function, or the chain rule. So if we write this as cos of x all cubed, so we need to write it that way. Bring your power down, subtract 1 from the power, and then multiply the derivative of the bracket, which is minus sine of x. So we can write that as 3 sine of x cos squared of x in the end, because it's minus there, minus the sine out the front, and cos squared of x. So we treat this one, it's not x cubed, it's cos cubed. So it's cos of x to the power of 3. G is a product rule. Derivative of e to the x is e to the x times the tan x, and then the e to the x times the derivative of tan x is secant squared. E to the power of tan x, though, is e to the power of a function, which is the derivative of the function times e to the power of the function. So notice, again, we applied the chain rule in that situation. Quotient rule being applied here, so and that's how we're getting this one. Derivative of the first one times the denominator, minus the top function times the derivative of the denominator over the tan squared. Leave it in that form. Same with this one. Derivative of x times the cos x minus x times the derivative of cos x, which is sine x, and we can clean it up. It's all over the denominator squared. So tan of e to the x, again, derivative of a tan function becomes the derivative of the function times secant squared of the function. And sine x over x squared is a quotient rule. So we apply our quotient rule. Sine x goes to cos x times the x squared, and the sine x and the 2 times 2x over the denominator squared, and just clean it all up. So using all our different rules, we make sure we get our differentiation correct.